Have you ever seen the sun and wondered how big it is? Now imagine that you are one of the unfortunate few who are close enough to the sun when it's at its most violent, giving off massive bursts of radiation. You're inside a star, a place where nothing can escape its grasp, not even light. This is what a black hole looks like. The thing is, space is really, really, really big, and we are just tiny insects crawling around on this planet. So let's take our trip into deep space to see if we could find out whether or not our entire universe is trapped inside a giant black hole. First things first, what exactly is a black hole? Well, that's actually quite difficult to explain. A black hole is basically a region in space where gravity is so strong that not even light can escape its pull. Imagine squeezing an entire star that's bigger than our sun many times over and then compressing it down to a single point. The amount of mass packed into such a small area creates a gravitational pull that is literally thousands, nay millions of times stronger than Earth's gravity. If you were anywhere near a black hole, you wouldn't even have time to take a selfie before being ripped apart by its gravity and then devoured by the singularity. Now, while black holes might seem scary, they are truly fascinating objects that have captivated the minds of scientists and space enthusiasts alike for decades. But here's the kicker. We don't actually know how they work. Sure, we've got some theories, but we haven't actually been able to observe one up close and personal. There are a few ways to detect a black hole. We can observe the effects of its gravity on nearby matter, such as stars or gas clouds, watch it gobble up light and other forms of electromagnetic radiation, or detect the telltale signs of material being slung around it at high speeds. But all these methods only tell us so much. We can't actually see what a black hole is made of because, well, it's a black hole. It's like trying to see inside a box in the dark. Despite the challenges, scientists have come up with some pretty creative ways to try and peer into the abyss. One approach is to send in robotic probes equipped with cameras and other instruments to measure things like temperature, radiation levels, and gravity. However, getting a probe past a black hole's event horizon, the point of no return, is easier said than done. The intense gravity and radiation would likely destroy any spacecraft long before it got close enough to make any meaningful observations. Another approach is to use powerful telescopes on Earth and in space to look for signs of activity around black holes. By observing the behavior of stars and gas clouds near a black hole, scientists can learn more about the nature of these mysterious objects. One example is the Event Horizon Telescope, which captured the first-ever image of a black hole's event horizon in 2017. But what if we could get an up-close view of a black hole without actually going there? Scientists are exploring ways to use virtual reality to simulate what it would be like to travel inside a black hole. By creating a computer-generated environment that mimics the intense gravity and radiation of a black hole, researchers hope to gain new insights into these enigmatic objects. But why do we want to understand black holes anyway? Well, for starters, they're just plain weird. The idea of an object so dense and massive that not even light can escape its grasp is kind of mind-boggling. Plus, black holes play a crucial role in the evolution of galaxies, and by studying them, we can learn more about the structure and behavior of the universe as a whole. Who knows? Maybe we'll even find some answers to some of the deepest questions in physics along the way. So while actually going inside a black hole might be a bit of a pipe dream, there are still plenty of ways to explore these fascinating objects without risking our own safety. With the help of cutting-edge technology and a little bit of imagination, we may yet unlock the secrets of black holes and better understand our place in the cosmos. Now that we know what black holes are, let's talk about whether our entire universe is trapped inside one. This is where things get really interesting. You see, while it's easy to dismiss the idea of a black hole universe as just another crackpot theory, there are actually some scientists who take it seriously. And hey, who are we to argue with the experts? One argument for the black hole universe theory is that our universe seems to be expanding at an accelerating rate. This could be explained if our universe were trapped inside a black hole and was being pulled outwards by its immense gravity. Another piece of evidence comes from the cosmic microwave background, the faint glow of radiation that permeates the universe. Some scientists believe that the pattern of this radiation may actually be a signal of our universe's birth inside a black hole. However, there is one major problem with this theory. Black holes are known to have a very specific size-to-mass ratio. In other words, if you know the mass of a black hole, you should be able to calculate its size pretty easily. But if our entire universe is trapped inside a black hole, that would mean that the universe would have to be incredibly dense, much denser than any black hole we've ever seen. This raises some serious questions about how a black hole could maintain its stability and whether it could actually hold our universe together. Not to mention that if our universe were trapped inside a black hole, we wouldn't be able to see anything beyond the event horizon. Yet somehow we can observe things like other galaxies and even the cosmic microwave background, which suggests that our universe must be expanding faster than light. That would violate the very laws of physics. Of course, scientists are always coming up with new theories and revising old ones, so who knows? Maybe one day soon someone will come along and figure out a way to make sense of this apparent paradox. But until then, we can rest easy, knowing that our universe is probably not trapped inside a black hole. Unless, of course, you're watching this video from inside a black hole. In that case, forget everything I just said. You're doomed. Let's take a journey back to the beginning of time itself. According to the Big Bang Theory, our universe began as an incredibly hot and dense singularity. Then, over billions of years, it expanded and cooled, eventually giving rise to the stars, galaxies, and planets we know today. But what if there was more to this cosmic creation story? What if the Big Bang wasn't the beginning, but rather the end? Imagine our universe as a tiny bubble floating inside a vast ocean of blackness. Each bubble represents a different universe, with its own physical laws and constants. Some bubbles may contain stars and galaxies similar to ours, while others may be filled with strange and exotic matter or exist in dimensions beyond our own. According to this theory, the Big Bang occurred when two universes collided, causing our current universe to expand outward and carry the remnants of both into existence. But wait, doesn't that mean that our universe is infinite? Well, not exactly. See, our universe isn't just expanding, it's also accelerating, which means that the farther away something is from us, the faster it's moving away. This gives rise to a few, well, issues. For example, if the universe is infinite, then that means that everything is infinitely far away from everything else, which isn't really the case. Plus, if the universe is infinite, then that means that there would be infinite copies of us, living infinite lives across infinite universes. But we only have one life, one that we're currently living right now. So the universe can't be infinite. It has to have a boundary, a wall that we can't see but are constantly bumping up against. But here's the real kicker. What if the universe isn't just infinite, but also closed, like the surface of a sphere? In this scenario, there would be no boundary to the universe, but it would still be finite. We could travel in one direction for trillions of years, but eventually we'd end up back where we started. This brings us back to black holes. What if there was a black hole at the center of our universe? Not just any black hole, but a supermassive one, millions or even billions of times larger than our sun. As our universe expanded after the Big Bang, this black hole would have grown in size, consuming everything that got too close, including stars, gas, and even light. Eventually, it would have become so massive that it would have ripped apart the very fabric of space-time, creating a massive wormhole that would allow us to travel back in time. If you're confused, don't worry. This is all really confusing. Basically, scientists have observed that the expansion of the universe is speeding up, which means that the universe must have a finite amount of matter and energy in it. If the universe had infinite matter and energy, then it would be expanding at a constant rate. But since the universe is speeding up, it must have a boundary, a wall that we can't see but are constantly bumping up against. Now, we haven't actually seen this wall yet, but we'll know it when we see it. When we observe galaxies that are so far away that their light has been stretched to the point where it can no longer be observed, we will know that we have reached the edge of the universe. At this point, we can turn around and head in the opposite direction, traveling back in time until we reach the beginning, or rather the end of the universe, the Big Crunch, when all of the matter in the universe falls into a single black hole. This is where our journey into the heart of a black hole ends. But don't worry, you don't need to travel inside a black hole to experience the unknown. All you have to do is watch this next video.